Good afternoon. Hello. Good afternoon. Hello. Hello. Good afternoon. So let us start. Today we are going to discuss about the aqueous mining methods. Aqueous mining methods. So aqueous means by using the water force. By using the water force, how the mining is carried out, that method is called aqueous extraction methods of the minerals. So the aqueous extraction methods depend on water or another liquid. Either you can use water or you can use another liquid such as dilute sulfuric acid, weak cyanide solution, or ammonium carbonate to extract the minerals. For the extraction of the minerals, if you are using the water, it is fine, but you can also use another liquid or dilute sulfuric acid, weak cyanide solution, or ammonium carbonate, depending on the type of mineral you are going to extract. You have to use water or another liquid for the extraction of the minerals. That method is called your aqueous extraction methods. So the first method of aqueous extraction is called your placer mining. We have seen that placer deposits are mined either by hydraulic mining or by dredge mining or by sluicing or by panning. So the placer mining methods are categorized into 4 groups. One is called hydraulic mining. By the help of water force you are mining. Dredging by using the dredge machines. Sluicing by using the sluices. Panning by using the pans. And the second method of aqueous extraction is called your in situ leaching or solution mining. In situ leaching or solution mining. And third type of mining method, aqueous extraction method, is called undersea mining. Undersea mining. So the placer and solution mining are among the most economical of all mining methods, but can only be applied to limited categories of mineral deposits. So where you can use the placer mining and solution mining, it cannot be used for all type of minerals. So the placer mining and solution mining are uh, among the most economical of all mining methods, but though they are very, very economical, you cannot use this method of mining for all type of minerals. They are applied only to limited categories of mineral deposits. So the placer mining, what is placer mining? Placer mining is used to exploit loosely consolidated deposits. If the deposits are loosely consolidated, then you can go for placer mining. So what type of minerals you can mine by the help of placer mining? Like common sand and gravel, gravels containing gold, tin, diamonds, platinum, titanium, or gems. So these are the type of minerals which can be mined by placer mining methods. So placer mining is used to exploit loosely consolidated deposits like common sand and gravel, or gravels containing gold, tin, diamonds, platinum, titanium, or gems. So there are two types of placer mining methods are there. There are two types of placer mining methods are there. One is called hydraulic mining. Hydraulic mining by the help of water force. Generally, hydraulic mining is used for weakly cemented near the surface ore deposits. If the ore deposit is situated near to the surface and they are weakly cemented, then you can go for hydraulic mining. By using the water force, you can break the minerals and exploit the minerals. So hydraulic mining of a placer gold deposit uh, is mined by this method of mining, hydraulic mining method. So how the hydraulic mining is carried out? So there is a hydraulic king or monitor, hydraulic giant or hydraulic king utilizes a high pressure stream of water. You have to use high pressure stream of water that is directed against the mineral deposit. The high pressure water stream is directed towards the mineral deposit normally, but not always a placer, undercutting it and causing its removal by the erosive action of water. So this is called your hydraulic mining. Then what is dredging? Dredge mining. Dredging generally used most often for mineral sands. Generally used most often for mineral sands and some near shore alluvial diamond mining operations. So dredging performed from floating vessels, which accomplishes the extraction of the minerals either mechanically or hydraulically. So in the case of dredge mining, it is generally used most often for mineral sands and some near shore alluvial diamond mining operations. So dredging is performed in a floating vessel, which accomplishes the extraction of the minerals by use of some machines or by using the water force. So dredging is a method which often used to bring up underwater mineral deposits. If the mineral deposit is below the water body, then dredge mining method is carried out. Although dredging is usually employed to clear or enlarge waterways for boats, it can also recover significant amount of underwater minerals relatively efficiently and cheaply. So this is a very cheap method of mining underwater mineral deposits very efficient. So, so placer mining. So what is placer mining? So placer mining, this is the method of placer mining for gold deposits. The local people, they are collecting the gold deposits by using the placer mining method. So placer mining using running water. It is carried out by the help of running water. The miners, these are the miners, shaved through material in riverbeds, riverbed mining. Colton miners, California's gold rush of 1849, was very old method of gold mining. Debris washed into streams, makes them uninhabitable for wildlife. It disturbs the stream banks, causes erosion. It harms riparian plant communities. That is why this method of mining was uh, abandoned and the new method of mining is established. So, what is a sluicing method? Sluicing method. This is a sluice box. This is a sluice box. So, sluicing method. In this method, water from the flowing stream is diverted into the area occupied by alluvial deposit through a channel. Through a channel. Men standing on the banks of the channel shovel the placer material into the water, and the water carries the placer deposits, and they are filtered. They are collected in these sluice boxes. So that is why this method of mining is called sluicing method. Then there is another method of mining is there, which is called alluvial mining. So the alluvial mining is carried out for the alluvial deposits by using a pan. This is a pan. This is a circular pan. So by the help of this pan, the alluvial mining is carried out. So it is a method of extracting minerals by dredging alluvial deposits. By dredging alluvial deposits. Different methods are there. You can use the pan and batia. In this manual method, this is a very manual method. The soft alluvial material dug up is placed in the pan or batia and washed. The mineral is washed and collected. Then you can use the rockers. This is a rocker system. This is a rocker system. So the rockers can be also used for the lesser deposits. A rocker nothing but consists of a metal screen, a metal screen mounted at the bottom of a strong wooden box and stand on two semicircular iron hoops. Two semicircular iron hoops are there below this. A handle is also fitted. There is a handle fitted to one side of the box. Then you, by the help of this handle, you can do the rock and roll motion given to this rocker. So that is what is called a rocker, uh, uh, which consists of a metal screen mounted on a wooden box. So the hydraulic mining of a placer gold deposit. This is the placer gold deposit. So the by the help of water force, this is the water, high pressure water is directed. Why high pressure water is directed towards the by the help of a monitor towards the mineral deposit. So the high pressure water uh, disintegrates the mineral deposits and it is carried through ground surface to the rifle box. This is the rifle box which uses mercury for gold recovery. So this is the tank. This is the this one is the monitor, high water pressure monitor, Stang intelligent monitor. Operator controls the high pressure water discharge point mounted on a skid, mounted on a screen. So this is hydraulic mining, which is called hydraulic. So this monitor, high water pressure is directed towards the mineral deposit. Here also, the high water pressure is directed towards the mineral deposits. So that's why this method of mining is called hydraulic mining. So then another method of mining is there, which is called dredge mining, dredging. Typical bucket line dredge. This is a typical bucket line dredge. So this is the floating vessel of which this dredge machine is operated. So dredging is a method. It is a method of mining often used to bring up underwater mineral deposits to collect to extract the underwater mineral deposits. So the dredge machine is used. Although dredging is usually employed to clear or enlarge waterways for boats, it can also recover significant amounts of underwater minerals relatively efficiently and very cheaply. Okay, so this is called your dredge mining. So what is dredging? Dredge mining or dredging, it is a method often used to bring up underwater mineral deposits. The deposits, mineral deposits, which are lying below the water body. So those type of deposits are mined by dredge methods. Although dredging is usually employed to clear or enlarge waterways for boats, it can also recover significant amounts of underwater minerals relatively efficiently and cheaply. Okay. So dredging. So what is dredging? So dredging, this method is mostly used for pressure mining deposits, pressure deposits. The dredge is large, flat bottom barge. It's, it is provided with a chain of large shallow pockets away, which is lowered down the bottom of the pond from where soils are brought up to the surface. So this is called a dredge mining. So what is dredging? Dredging is a method often used to bring up underwater mineral deposits. Although dredging is usually employed to clear or enlarge waterways for boats, it can also recover significant amounts of underwater minerals relatively efficiently or very cheaply. So whatever we have discussed till now, so they are all related to pressure mining deposits, alluvial mining deposits, which is carried out by four methods of mining. One is by hydraulic mining, second one is by dredge mining, third is by sluice boxes, canning sluices, and by the help of the um, other machinery used for the unconsolidated sandy materials. So the second method is called your in situ leaching or solution mining. In situ leaching or solution mining. So what is solution mining? So solution mining is nothing but it is equal to solution mining in situ recovery of the mineral is equal to resources in a deep deposit. Resources in a deep deposit uh, are dissolved in a liquid and siphoned out. In the case of in situ leaching or solution mining, if the in situ deposits are at a greater depth, the resources are dissolved in a liquid and siphoned out to the surface. So what type of minerals are mined by solution mining? Salts are mined by solution mining. Lithium is mined by solution mining. Boron is mined by solution mining. Bromine is also mined by solution mining. Potash, copper, uranium. These are the type of minerals which can be mined by solution mining. Salts, lithium, boron, bromine, potash, copper, and uranium. These minerals can be mined by in situ leaching or solution mining. So if you are going for in situ mining, in situ leaching or solution mining, it will have less environmental than any other method of mining. So if you are going for solution mining or in situ leaching, the environmental impact, there will be less environmental impact compared to surface mining or underground mining. And this method of mining, solution mining, is less surface area area, you don't have to disturb a very large surface area like your surface mining. Here, very less surface area is disturbed if you are going for solution mining. This is the advantage of solution mining. Less surface area is disturbed. And the acids, heavy metals, uranium can accidentally leak. This is the problem. This is the problem associated with solution mining or in situ leaching. Certain type of acids we are using sulfuric acid. So these acids may leak out to the environment. Heavy metals may leak out to the environment. Uranium may leak out to the environment accidentally, which can disturb the ecosystem of the area. So this is the advantage. Less surface area is disturbed, but the problems associated with solution mining is that sometimes acids which are used for solution, heavy metals, uranium can accidentally leak and create environmental problem. So this in situ leaching or solution mining is used most commonly on evaporite, like your salt type of minerals, potash minerals, salt minerals are mined by solution mining or in situ leaching method of mining, because these minerals, this method used most commonly on the evaporites. Salt evaporates, potash is also evaporite type of mineral. So for these type of minerals, solution mining in situ leaching is carried out. And sediment hosted uranium deposit can also be mined by solution mining method. Sediment hosted uranium deposit can also be mined by in situ leaching or solution mining methods. And also, to a far lesser extent, to recover copper from low-grade oxidized ores, you can also use the in situ leaching method or solution mining method. The dissolving solution is pumped into the ore body from a series of injection wells. In the case of a in situ leaching method, the dissolving solution acid is pumped into the ore body from a series of injection wells and is then pumped out to the surface together with salts dissolved from the ore body from a series of extraction wells, production wells. So the metals and minerals commonly mined by solution mining method is listed below. What are the minerals? What are the metals which can be mined by solution mining method is tabulated in this table. So dissolving agent specified in each case is given table also. So the metal or mineral which can be mined by in situ leaching method is gold. The gold deposits can be mined by in situ leaching method. So the approximate primary production from the gold mines will be 35%. And the dissolving agent used, dissolution agent or method used is sodium cyanide is used. If you are mining gold, then you will get 35% production and you have to use a dissolving agent. Sodium cyanide is used for gold mining. Silver, if you are mining silver or silver deposits, 25% production would be there. And you have to use sodium cyanide also. Just like your gold mining, silver mining is also carried out by sodium cyanide solution method. If you are mining copper, at 30% production, 30% production. And what are the chemical agent you are going to use in the case of copper deposits? Sulfuric acid is used, ammonium carbonate is used. Okay, you can use the sulfuric acid, ammonium carbonate, which is an alkali, NH4 CO3. Alkali, this is a okay. for the copper deposits. And if you are going to mine the uranium deposits, in the case of uranium mining, in situ leaching is very successful. 75% production would be there in the case of uranium mining. But the solution you are going to use it sulfuric acid or ammonium nitrate, sulfuric acid and ammonium nitrate, just like your copper mining. So uranium mining, copper mining, they use sulfuric acid and ammonium for the extraction of the uranium and copper from the deposits. But in the case of a copper deposit, you get 30% only production, whereas in the case of uranium deposits, you get 75% of the production. And the common salt is mined by using water, only water, no acid, no alkali. So if it is a common salt mining, you get 50% production. For potash mining, you use the water, you get 20% production. In the case of trona, you get 20% production by using water force. And if you are mining boron, you get 20% production, and the acid used is hydrochloric acid, HCl. Magnesium also can be mined by in situ leaching, where you get highest production. 85% production is obtained, magnesium production is obtained from the seawater lake brine processing method. Seawater lake brine processing method, magnesium 85% production you get from the seawater lake brine processing method. And for sulfur mining, you get 35% production, and you have to use hot water, melting water, hot water. For lithium production would be 100%, highest production would be there. You have to use lake brine processing method. So the in situ leaching or solution mining method is carried out for the different type of minerals and metals like gold, silver, copper, uranium, common salt, potash, trona, boron, magnesium, sulfur, and lithium can be mined by in situ leaching method. So out of these minerals, the lithium can be extracted 100%, magnesium can be extracted 85%, and uranium can be extracted 75%, common salt is 50%, and the rest of the minerals about 35%, 25%, or 30%, or 20%. Highest production you get is lithium, second highest production is uranium, and fourth highest production is common salt. So this is the method of extraction, which is called your in situ leaching or solution mining method. So how the in situ leaching is carried out, solution mining method is carried out. So this is the deposit, the bottom one, this is the deposit, this is the deposit, salt bed deposit. So from here, from the surface, hot water is supplied to this cavity. This is the cavity. To this cavity, you inject the hot water. So the hot water, when it comes in contact with salt, there will be dissolution. Salt and water, they will mix together, and then by this annular surface, the brine is pumped out to the surface. The brine is pumped out to the surface, and salt is separated out from the brine. And so this is called your in situ leaching. Two means one through the one pipe you are sending the hot water, through other pipe you are taking out the brine water. Okay, so here the in situ leaching sulfur mine. This is the in situ leaching salt mine. This is in situ leaching sulfur mine. This is the sulfur deposit, sulfur formation. So the through the one pipe, compressed air is sent down the hole to this cavity. So compressed air will go, and so the when the compressed air will go, so this air will agitate the sulfur deposit and the molten sulfur. The molten sulfur is, so not only the compressed air is going, hot water is also going to this cavity. Compressed air along with hot water is injected to this hole, to this cavity. So whenever hot water and compressed air, they agitate this sulfur, so they get molten sulfur, and this molten sulfur is pumped to the surface in the form of sulfur, water, and air. Sulfur, water, and air is pumped to the surface. So this is the in situ leaching method for sulfur mines. So solution mining, these solution mining includes both borehole mining, such as the methods used to extract sodium chloride or sulfur, leaching either through drill holes or in drum, or if this of to leaching or solution mining. What are the advantages you get from the in situ leaching? There is no solid waste generated in the case of the in situ leaching method. No solid waste. Liquid wastes, low concentration brines with no market value can be re-injected into the stratum being leached. Also reported that wastes are injected into a separate aquifer. Okay, so liquid wastes, whatever you are getting, they can be again re-injected into the. So these are the advantages of in situ leaching. No solid waste, and whatever liquid waste you are getting, you can again re-inject to the stratum. But the problems associated with in situ leaching are little control of the solution underground, and it is very difficult in ensuring the process solutions do not migrate away from the immediate area of leaching. Main impact of evaporite is derived from the surface shallow groundwater contamination. Evaporation evaporation. Stagnant solutions can be highly corrosive and hypotoxic and can react with the soil materials used in pond construction and may migrate to surrounding areas through seepage, overflow, and wind-blown spray. The other problems associated with in situ leaching is surface subsidence and the development of sinkholes may also occur after prolonged solution mining. If inadequate unmined material is left to support the these are the advantages of in situ leaching. No solid waste, liquid waste can be re-injected to the stratum. But the problems associated with in situ leaching is you have little control of the solution in the underground. Main impact of evaporite is in the in situ leaching is derived from the surface or shallow groundwater contamination in the vicinity of evaporation ponds. Surface subsidence, development of sinkholes may occur after prolonged solution mining is carried out. Examples of evaporite deposits. What are the deposits which are called evaporite deposits? Evaporite deposits has been used for many decades to extract soluble evaporite salt, such as halite. Sodium chloride is a evaporite deposit is an evaporite also an evaporite somite is also an evaporite deposit canalite from buried evaporite deposit UK, Russia, Germany, Turkey, Thailand. So these are the different type of evaporite deposits which are mined by in situ leaching method. A low salinity fluid, either heated or not, is injected into the underground directly into the evaporite layer. The pregnant solutions, brines, are withdrawn from recovery boreholes and are pumped into evaporation ponds to allow the salts to crystallize out as the water evaporates. This is the method of extraction of the evaporite deposits by using the in situ leaching. See the figure shows evaporation pond. This is the evaporation pond. So old underground mines consisting typically of room and pillar method of working are often solution mining method to recover whatever mineral is left out in the pillars. Okay, so the in situ leaching mining solution mining method is applicable to the evaporite deposits. So we have seen that the uranium is mined by the in situ leaching method or solution mining method. And in the case of uranium heap leaching, you get 85% production. So the uranium heap leaching occurs in tetravalent and hexavalent forms. Uranium is in tetravalent or hexavalent form. Tetravalent uranium requires oxidation during the leaching process. Leaching in acid or carbonate medium, depending on gangue and consumption, lower recoveries in carbonate medium. If you add suitable oxidizing agents such as H2O2, MnO2, NaClO3 for regeneration of iron Fe3 or by bacterial oxidation. Typically, 0.5 gram per liter iron ORP, which may be produced from gangue dissolution. So you can also go for bacterial leaching offers various advantages of reduced oxidizing agent and generation of acid from sulfide minerals such as pyrite, as well as liberation of mineral from sulfide host. So readily leachable minerals are acid leached at a pH value of 1.5 to 2 and at a temperature of 35 degree to 60 degrees centigrade, which are suitable conditions for bioleaching. Refractory minerals require higher temperature, 60 to 80 degrees centigrade, stronger acid, up to 50 gram per liter. So these are the common uranium minerals mined by solution mining method. Leachable oxides, uranite, leachable silicates, refractory complex oxides, hydrated oxides, silicates, vanadates, phosphates, carbonates, arsenates, hydrocarbons. So this is the mineral uranite and different type of minerals. Uranium minerals this is the formula for the uranium minerals, and this is the operation. Rossing, Dominion, reefs, result in these are the operations carried out for the uranium leaching method. So the uranium deposits, uranium minerals are soluble in acidic or alkaline solutions. That is why you can use the acid, you can use the alkaline also. The production fluid consisting of the water-soluble uranyl oxynion is subject to further processing on surface to precipitate the concentrated mineral product, yellow cake. You get the yellow cake. U3O8 or UO3, which is called a yellow cake. So this acid leaching fluid like a sulfuric acid, fluor, oxidant, nitric acid, hydrogen peroxide, or dissolved oxygen, or you can use the alkali leaching fluid like ammonia, ammonium carbonate, bicarbonate, sodium carbonate, or bicarbonate. So these are the leaching fluids. The hydrology of the aquifer is irreversibly changed. Its porosity, permeability, and water quality is changed. It is regarded as being easier to restore an aquifer after alkali leaching is carried out. So this is the method used for uranium deposits. So this heap of minerals, heap leach operation installing a plastic membrane liner also used for the leaching purpose. The layout of copper bioheap pilot plant. This is a layout of copper bioheap pilot plant. Okay, so this is the photograph auxiliary ponds. This is the raffinate ponds. This is the heap, the copper heap, and this is the crushing agglomeration plant, and this is a drum agglomeration. This is the humidification layer with drainage pipes. So the advantages and disadvantages of heap leaching. What are the advantages you get from heap leaching? What are the disadvantages you get from heap leaching? See, the advantages of heap leaching are low capital cost and operating cost is very low. Absence of milling step. There is no need of doing any milling. May require crushing and agglomeration only. Simplicity of atmospheric leach processes are there. Can be used to treat low-grade ores, stressed materials, and small deposits. Absence of liquid-solid separation state allows counter current operation. Metal tenor may be built up by recycling solution over the hips. But the disadvantages associated with heap leaching are lower recoveries than the mill float or mill leach process, long leach cycles and hold up period is there, lengthy experimental programs are there, large footprint is there, acid mine drainage problem may occur in your mining area. So these are the advantages and disadvantages of your heap leaching. But inside the sea, if you are going to mine the deposits, it is called undersea mining method. So seabed mining is carried out for the undersea mining deposits. We extract the minerals like magnesium nodules from the seawater. From the seawater, you can extract the magnesium minerals. The minerals are dredged from the ocean floor. Dredge mining is carried out for the minerals which are lying in the ocean floor, like sulfur, phosphate deposits, calcium carbonate for the cement plant, silica, insulation, and silica is used for insulation and glass industry, copper, zinc, silver, gold, etc. are dredged from the ocean floor. Manganese nodules, these are the manganese nodules, small ball-shaped ores scattered across the ocean floor can be mined by undersea mining methods. Mining them is currently uneconomical. Now, these manganese deposits or any type of deposits which are lying at the bottom of the sea, if you go for mining, they are not economical at present. But time will come when the mineral deposits from the surface will be exhausted, then you have to enter to the sea to mine these type of minerals. Manganese nodules are found in Pacific Ocean. Ore nodules crystallize from hot solutions arising from volcanic activity. They contain manganese, iron, copper, and nickel. The hydrothermal vents may have gold, silver, zinc. Mining would destroy the habitats and organisms and release toxic metals that could enter the food chain. This is the problem associated with undersea mining methods. So mining ocean mining methods, the mineral deposits which are lying in the ocean sea floor, the methods which are used is called ocean mining methods. Minerals found in seawater but occur in too low of a concentration. Continental shell can be mined. Deep ocean are extremely expensive to extract, not currently viable. If the deposits are lying at a great depth of water, it is very difficult and very expensive to extract the deep sea mineral deposits. So the ore is controlled to different processes. The drill holes, three-dimensional of the drill holes is the map geology with DGPS. This is the electronically log holes. This is model geology and ore zones. This is the central database. This is the estimated grade. This is the design of ore blocks. This is the mining, ore control, modular mining, and reporting system. This is the reconciliation. This is the ore control process carried out in the mining environment. Controls of gold mineralizes. The gold deposits which are found in the earth crust also can be mined by the method explained here, mining methods by surface mining methods. So these are the controls of gold mineralization in the surface mining method, and the controls of gold mineralization simulation modeling is carried out by this method. And this is the mining view where the gold mining is carried out. This is the surface mining method, and this is the control of gold mineralization in surface mining methods. So whatever method of mining, surface mining methods you are adopting, you have to go through some mining process, flow chart of mining process. First, the geologists, they have to explore the mineral deposit, exploration of the deposits by the help of the geological information by drilling the holes, reverse circulation drilling, diamond core drilling is carried out to estimate the reserve resource. Then surface graph samples are collected to find out the grade of the deposit. Geological mapping is carried out to find out the dip and strike of the deposit and extension of the deposit. After that, the mining engineers, they go for planning. Mine planning is carried out by mining engineers. Then production engineers, they plan for the scheduled production of the mineral deposit. The mining geologists, they control the grade of the deposit. Grade control plan and drilling is carried out by the mining geologists, and they design the ore blocks by the help of drill holes. And you drill the holes, then you blast the materials and exploit the mineral. So this activity can also be carried out by a mining contractor. So this is the mining flow chart, starting from exploration of the deposit to the uh, uh, drilling and blasting. So exploration is carried out by the geologists, resource model to find out the reserve of the deposit. Exploration is carried out by the geologist by drilling the holes. Two methods of drilling is carried out: reverse circulation drilling method, diamond core drilling method. These drilling methods are carried out to find out the grade of the deposit, depth of occurrence of the deposit, quantity of deposit present in the Earth's crust. By collecting the surface graph samples, you test it in the laboratory. Then you carry out the geological map. You prepare the geological map showing the deposit configuration and area of the deposit. Then after that, the mining engineers, they carry out the design and planning. Planning and design of the mines are carried out by the mining engineers, and they go for production of the minerals. Mine production phase, the engineers, they produce the minerals. So these are the steps you have to follow to uh, extract the mineral. And finally, the mining geologists also, while the mining is carried out, they control the grade, they control the plan and drilling, they control the grade control is carried out by planning and drilling and by designing the ore blocks, by designing the ore blocks. And frequently in the mines, you go for drilling and you go for blasting, and after blasting, the material is loaded to the shovels, loaded by the shovels to the dumpers, and material is taken to the beneficiation plant. And these activities, whatever is carried out, drilling, blasting, can be also carried out by the mining contractors. So this is the example of Gita mining production process, starting from the ore grade control drilling to blast hole drilling to changing of blast holes, charging of the blast holes, firing of the blast holes, and loading of the blasted rock by the help of a hydraulic shovel to the dumpers. Then ore halt to runoff mine stockpiles, and this is the pit layout of the pit. And waste material hauled to the dump yard. Mineral is taken to the beneficiation plant. Waste material is taken to the dump yard. Waste material top onto the dump, and reshaping is done. Reclamation, mine reclamation is carried out at the end. And the ore is stockpiled or loaded into the primary crusher, and crushed ore is stockpiled for dispatching to the user industry. So this is all you carry out, starting from the surveying to mining to drilling to pit design, loading, hauling, transportation. All the activities are carried out by the help of this method of mining. So today we have discussed about the aqueous mining methods by using the water force. Aqueous mining means by using the water force. So this aqueous mining method cannot be used for all type of minerals. There are certain type of minerals which are mined by aqueous method, by aqueous methods. So the water force is the driving force for exploitation of the deposits. And in the case of aqueous mining method, we have seen the uh, dredge method of mining, placer mining, dredge method of mining, placer mining, ground sluicing. These are the methods used for the different type of placer deposits. Then also we have seen in situ leaching method of mining and solution mining methods. So these methods are in an where consolidated minerals are there. So that yeah, this exploitation of those type of minerals. So the Hydraulic is the method uh, of extraction of the unconsolidated alluvial deposits, lesser deposits by using the high pressure water jets. So this is all about today's class. Discuss the aqueous mining. Thank you, thank you, thanks.
Thank you, sir.